want to introduce you guys to Mark. Yeah, Mark is from West Virginia.
West Virginia.
And we're building a 128 for him for his, what year is your bike again?
2019.
2019.
All right. Go down 1 through 6.
All right. I'm going to give it one more go through just to be sure. So, and then you have different types of things. You have torque, you know, basically torque spec. Then you also have what's called torque to yield. And that's when you start measuring, you know, like X torque plus a certain number of degrees to allow for fastener stretch and all that. So if you're ever tightening a bolt that is a torque to yield bolt, that bolt is designed to never be used again.
Ah, okay.
All right. So if you've got, you know, bolts like this, you're okay to reuse them, but still, that's another reason we look at the threads and all that other kind of stuff too. Now, this is an exceptionally common issue I have seen where folks grab these plates, put them on. All right. Remember, this is a seal. So what this is doing is blocking off the hydraulic, the hole for the hydraulic tensioner.
Oh, yeah.
But inspect that closely and tell me what you find. Flip it over.
Yeah, it's got the sticky. There's stickiness on here, right?
That bump right there.
Oh yeah. Oh yeah.
If that went on there, you would have no hydraulic seal. So
interesting.
I'm going to put it on there in this direction. I'm looking for my hand file. But the biggest aspect is this is an important, very small detail, so you're not bleeding off hole pressure. You want to inspect.
And it's so small.
Yes.
Right. You have to look for it.
You have to look for it, and you want to run your finger, because these are just stamped steel or aluminum. They're just stamped, right? So you want to run your finger along the edges. You want to make sure there's no burrs or anything that would prevent the seal. And even if you run your finger along here, you can feel just on that edge, that slight burr. That's just enough to hold it off. Yeah, it's just enough to hold it off. So the other thing I'll do is I walk over to my surface plate and I set it down. If it's bowed in the middle, I'm going to flip it and mount it the other way.
Okay.
All right. Now this is called a sine bar. Okay, it's what you use on a milling machine to set different angles to machine spit. But anyway, this is machined what you could call perfectly flat. All right, so that's what I'll compare it to. See that bump that's still there?
Yeah.
All right, let's flip it over. We see we're perfectly flat.
Yep. So now you've determined which side to use.
Right. So that's the side of it. And of course, that's also the side that we had filed.
Yep.
If we hadn't filed it, we would have had a little bit of a leak right there.
Yeah, that's a big deal.
Now you can go an extra step. What I used to do years ago, I would actually put blue Loctite on it, because Loctite will seal, blue Loctite will anyway, seal up to about in some cases up to like a 20 thousandths gap. But then I got thinking about it and looking at bikes that I hadn't done it on or anything else, I never
noticed the difference.
And
you know, we were talking earlier and how most of these problems seem to be, they accumulate, right? You can't point your finger at any one thing, but a series of things, right? And things like that seem to me to be the things that add.
Yes.
You know, a little here, something else, a little bit, before you know it, all put together, and you got a problem.
Compounds quickly.
That's the same torque spec as the...
Those are quarter 20s. Quarter 20, 109 to 120 inch-pounds. As far as, again, SAE standards go. The reason, well, I always hit it down the middle. So typically the reason why torque specs are what they are is your lowest setting is to a large degree at what point a gasket would leak. Okay. It's about the clamp load of a gasket, okay? The top end is the point you start weakening the threads, potentially the threads.
Okay.
So I set it in the middle. Well, if I ever wanted to come back and check torque, so let's say you've Loctited and torqued brake caliper bolts and rotors and stuff like that, you always set your torque wrench on the lowest of the range. Check it to see if it's loosened, because if you put it higher than that, you can break your Loctite loose.
Ah, okay, clever.
So yeah, so if it's 40 to 50, most people will shoot it down the middle at 45. Set your torque wrench at 40.
That'll tell you if you've moved.
Right, you haven't broke your Loctite loose. Otherwise, the proper way would be to then take the bolt out, re-Loctite it, and put it back in.
Yep.
So, just a little
Interesting. And folks being aware that your knowledge level is significant. That's the kind of stuff they're talking about.
No. All right, so we always like to do little pumps. We know you've got less than 1,000 pinion shaft run out, right?
Yep.
But you can see the pump does move. It's designed to some degree, right? There's a little margin of error. So I like to rotate it, and that will begin to kind of center those the gear rotors in there. But then I'll kind of bottom this out and then back it off. Now let's back it off just a little. And we're going to spin it again. Back it off just a quarter turn. You notice how the bolts are going in. A bolt that long has run out, right? So what I'm trying to do is, see that?
Yeah.
All right, so I don't want to just force in a bolt and then do it. So I'm trying to do all four. The idea just slowly walking this thing in. See all the run out on the bolt?
Yeah, it's big.
All right, so we want to back it off about a quarter turn. I'll do that again. Then I'm just going to finger snug that one just a little. I think that hole's got a little anodizing in it. Now I'm just going to finger snug it. Do it again. Finger snug it. Again. Go. Perfect. In other words, the crank didn't change. Nothing's in a bind. Now I've already cleaned this out and this out. This has cheating holes on it.
Yep.
It's going to be in the threads. It's going to be in there. You need your Loctite to hold. So I always brake clean, and then, because remember, this is all the way through the crank, right?
Yep.
So I'll brake clean on the cotton swab. Reach up in there, and I'll keep just going into the threads with a cotton swab until I see no more oil on it.
Okay.
And then I stop. I'm not going to put Loctite on it yet because I may end up having to take it back off, right? So we're doing the backlash thing. Okay, can't stress enough. What I'm about to do is a tap. Tap.
Now, what are we doing there?
Putting the keyway in for the gear.
Okay.
Because it's a D, right?
That's what I get for looking away.
And my other. So I know that's a 1/2 inch. And one thing about doing this, it's a feel sort of thing. One, if you got, you know, that 3 thou run out thing on the crank, right? That gear can start getting really tight to get on there. That gear should pretty much walk in. That's the reason I put this one on first, right?
Yep.
So if you're getting close to that 3 thou, it won't just walk in that easy. You might have to rotate the crank a little bit to find
The sweet spot.
the little sweet spot to keep those gears from grinding together. So if it's good and you're golden, you should be able to hold the top gear and easily go in with the bottom. Okay, so all I'm doing is snugging it and make sure it's seated. All right, I need to walk that one on there a little bit more.
Very clever.
So you don't mess up the gears. All right, one of the big things, I'm looking at the gear alignment, and we should be we're dead on the money, and we're dead on the money on the center line. Okay.
Yeah.
All right, so what I want to feel, so we're basically at TDC on the rear cylinder right now, right? So
How do you know that?
I can see the 2 dots right there.
Okay.
All right, so that's going to be about 1 thou and a half. So let's rotate it a 1/4 turn. That's about 1 thou.
Now you're just showing off.
Let's come back around.
1/2 thousandth in your hand.
It's about 1 thou and a half. That's a 1/2. You want to try it?
So we're good.
I'm gonna get it. I'm gonna get it, and we're gonna check it. But we're gonna check it. Okay. Hey, you ready?
Go ahead.
All right. So we're back. We're back where we were at the beginning. Each one of these tick marks is 1/2 thousandths. All right. So right here, I said we're going to have 1 thou and a half.
There you go. That's pretty good.
So what is it?
1 thou and a half.
Thou and a half. Now hold that part out right there. Let's go 90 degrees. All right. Let's find the gear. There's your 1 thou and a half right there.
Yep.
All right. Check it out. So the other 90. If I remember right, this is our 1/2 thou spot right here.
There you go. Right on the money.
What have you got?
1/2 thou.
1/2 thou.
Pretty good.
Pull that one more time. Let's do the four side. People think I'm joking when I do that.
That's pretty cool to watch.
All right. Now let's get right here.
1 1/2, right?
There's your 1 thou and a half.
Yep.
All right. So in an ideal world, you would want 1/2 to 1/1000 all the way around. Okay. Now this, to explain why 3/1000 is that magic number. So for total run out, right, of whether gear drive is good or not. So you need 1/2 to 1 thou backlash for obvious reasons. So gears just don't chew themselves up. But you also have thermal expansion and all the things that happen in there, right? So what we're trying to achieve is that 1/2 to 1 thou all the way around. So you have a crank with 1 thou pinion shaft run out, and we have a range of 1/2 to about 1 1/2. So you're really average, you're golden. Remember, we're checking this dry without oil.
Yes.
Oil's going to take up a lot of room in there too.
Ah, okay.
Right.
So that's going to eat up.
The other 1/2 thou.
Yes.
Okay. So what's going to happen is it's going to take up the slack on that little 1 thou and a half. We're talking 1/2 thousandths of an inch, right? So oil's going to take up the slack on the other end. That 1/2 thou that's on the other end, it's an interference, so it's just going to squirt the oil out. So in other words, we've got a good average balance.
Yep.
But imagine if you had 3 thou run out, it would be impossible for you to have half to 1 thou backlash all the way around
Yes.
because that pinion shaft is moving up and down.
Yep.
All right, that makes sense?
Yeah.
Yeah, so that's one. All right, so now that we have that, I'm gonna pull these back out, Loctite them. We know we're good to go.
Hungry?
Do the chest covers and all that stuff go on, or do you wait till it's in the bike to do that?
No, the cam cover is the absolutely last thing that I put on because it makes it easy for me to see the TDC marks when I adjust my push rods.
Wow, okay.
All right, hear that? Now watch this. Just a small amount of assembly lube, that will go away entirely.
Nothing.
Nothing.
Very cool.
That is 100% proper way to set up gear drive. I mean, that's, and it'll be quiet as a mouse. It won't whine. It won't do its thing. No rattle rattle. Do what it's supposed to do. Nothing.
That's another reason I like swapping all that, the whole crankshaft out,
Right.
was to be able to get those gear drives.